My name is Miguel. I work at Igalia on the WebKit team, which is the team that we have, which is devoted to develop WPE, our WebKit port, especially intended for embedded devices. I've been working on this for 10 years now, and I have a lot of experience working with this, especially with the rendering pipeline. And as you know, WPE is this browser that is integrated into RDK and that is used to show regular web content together with Lightning applications. So we are facing many challenges we have been facing, are facing several challenges during these years when it comes to the evolution of WPE regarding graphics, because I'm going to be speaking only about graphics in this presentation. One of the things that we always had is that we had our custom WebGL implementation. As you know, WebGL is this API that allows to run OpenGL commands through JavaScript. Lightning is using WebGL to render their content. And we had a previous implementation that we did ourselves that was only 1.0 conformant. It was working fine, and we started with that, and the first versions on Lightning were using that without many problems. But we needed to improve that somehow. This is something that we were working on, and I will show you later how we handle this. The next problem that we are usually facing is that the rendering is slow, especially CPU rendering, which basically every time you need to put something on the screen, you need to render in one way or another. We are using mainly CPU, or we were using mainly CPU up until now. That's slow, especially on low-end devices. We need to improve that. That takes us to the next point, which is the general performance. Basically, if rendering is slow, everything is slow. So that's something you need to take into account. There are more considerations besides just rendering, but it's something that needs to be taken into account as well. Then we have security concerns, of course, always. Besides general security, for example, you have this requirement now for DRM content that decoded frames cannot live in the same process than JavaScript execution. So they cannot access the decoded content of the frames. And also, we have been following an integration on the different platforms based on having different backends. It was nice and it works, but we think that we can improve that. So we have been thinking on a way to improve that. So what we do so far? First, regarding the WebGL implementation, there is this library software developed by Google, which is called Angle. Angle is a generic WebGL 1 and 2 implementation. Wherever you put it, it will allow you to run that content as long as the libraries underneath allow it. For example, if you want to use WebGL 2.0, you need GLS3 on the system. We have adopted that. We have removed our custom implementation, and we have integrated Angle. And now we support WebGL both 1.0 and 2.0. And this already happened. It's available since 2.42, which is the stable release that happened last September, the past year. Then what we also been doing along this year is that we were doing our CPU rendering with Cairo. Cairo, while it's nice, it's a small library, very useful, but it didn't allow us to use the GPU, and on low-end devices, it's better in some cases to use the GPU for rendering than the CPU. So we decided to replace our Cairo implementation with Skia. Skia, again, is another library developed by Google, which is used by Chromium. So we decided to replace Cairo with that. We did that during this year, and we have that already working. Initially, we are following the same approach, and this is going to be released in 2.46, which is the release that is going to be happening this September. We have decided for the moment to use the same approach that we have with Cairo, which is to use the CPU rendering for the moment and use the GPU so far only for the canvas. But our plans are to make this better. But so far we have replaced Cairo with Skia in the same conditions, one with the other, and we are going to be improving this. So this is what we have done so far, and this is what we are going to do from now on. As I was saying, we need to, now that the Skia offers us the possibility to render both with the CPU and the GPU, we can try to use more the GPU for more content than just the canvas. And even more, we want to be able to use the GPU as another CPU to render the content and to be able to dispatch rendering requests to both the CPU and the GPU depending on the load of the system to achieve the rendering as fast as possible. This is something that we are already working on. We are having the first results. This hybrid mode that I'm mentioning here is this using together the CPU and the GPU. We are probably going to be able to upstream this probably during this month, and maybe we are able to port it already to 246 for one of the sub-releases that is coming later. Another thing that we are thinking of doing is that when you put the browser on a platform, the rendering is going to depend a lot of the characteristics of the platform. How many cores, whether the GPU is powerful or not. And in many cases, you need to tailor some parameters of the browser in order to achieve the best performance of that platform. This needs to be done by hand or by testing parameters, finding what's best for the platform. But we want to find a way to have a tool to do this automatically, basically. And we are thinking of that like running some program that you run before WPE that will test several rendering scenarios, check what are the best values for our configuration parameters, and then store them so WPE can use them. This is something that we have some ideas about how to do it, and I think it's going to be a blast if we do that. Then WPE uses several processes internally. Now, one UI process, which is kind of what we understand as the browser, it will create a network process to perform the network request. It will create a web process that is going to execute the JavaScript and perform the rendering. And we need to, or we would like to improve the way in which we share buffers between those processes in a way that we don't need to perform copies, and also buffers that can be rendered with the GPU. This ties a bit with the GPU rendered in the previous point. And for that, we need a way on every platform to share these buffers without having to do copies. On Linux, by default, or the most common approach is using DMA-buff, which allows you basically to share the buffers as file descriptors from one process to the other. And we already support this, but it is not available in some of the platforms that are used on set-top boxes. For example, for the Broadcom Nexus stack, we need to search for an alternative for it. We already have that, but some other platforms we're still looking for a way to do this buffer sharing. And why do we need this? Because we are going to introduce a new process, which is the GPU process, which is a process that is going to be dedicated to only performing rendering on the GPU. And this, if you remember, this restriction that DRM has about not running JavaScript on the same process where the decoded video frames are living, this is going to fix that, because the decoded frames are going to be on the GPU process, while JavaScript is going to be in the web process that we have now. Even more, there will be several web processes trying to render stuff, only one GPU process serving all those web processes, and this GPU process, for example, if there is a crash, only that process is going to crash and we can create a new one, but the web processes are not going to be affected. So the page is not going to be affected. The JavaScript that you have is not going to be affected by these crashes. So this is an isolation of the errors when rendering. Also, it's going to save memory because we don't have to have as many GL context in different processes. That's going to be centralizing only in a single process. So this is going to save memory. It's going to be awesome. Some other things we want to work on. As I mentioned, we had this backend system to integrate into different platforms. And we think this is making things more complicated in the end. Our idea here is to remove these backends and use this new buffer sharing mechanism that we are trying to find to share the buffers among our processes. So applications would only have to access the UI process, what we call the UI process. They can forget about everything. So it's whatever the browser does internally is not a matter for you. You don't need to know about that. We are going to implement, once we have an implementation for this buffer sharing for every platform, then your browser, if you want to use a custom browser that uses WPE or whatever, your UI process can just create the view, and give me the frames of the view, and I'll put it on the display, and that's it. And you don't care about anything else. That's gonna ease the integration a lot. And this is something that also we are already developing. It's working already for those platforms where we can have this buffer sharing. But we are hoping that we are going to be able to port this also to the set-top boxes that we are working with nowadays. And I guess this is everything that I plan to talk about today. So if there is any question around, any doubt,